So welcome to the Zoom session. I am recording this. I just wanted to let you guys know that, but the only thing that I'm going to record is my screen. So it's great to see you guys here. I miss you guys a whole bunch, and let's go ahead and get these notes down so you have them, and then I'll upload them into the classroom once I edited it out. Okay, so the next part of the series of videos, this is Charles' Law, and we ended up doing Boyle's Law last video. This is where we ended up with all our answers there, if you recall that on our session that we did on Tuesday. And these are up on Google Classroom for you can print these off if you would like. You don't have to, it's not a big deal. So the relationship between Charles' Law, between volume and temperature. And it says Charles' Law states that the volume of a fixed mass of gas volume varies directly with that of Kelvin. Temperature. So it's a direct relationship. One goes up, so does the other. If you were to look at this on a graph, it would be a nice direct correlation. You have a nice, once temperature goes up, so does the volume. So it's a direct relationship. And then on Boyle's Law, I forgot to mention that last time, if we were to do this on a graph, remember this is the inverse relationship between the variables that you look at. And if you were to put this on a graph, it would look like this. This is the classic Boyle's Law curve, okay? Showing an inverse relationship. So it's inverse. Today, we're going to look at Charles and Gay-Lussac's law. They're both going to look like this because they're both direct. Okay, they're both direct on the graph. So anyhow, the variables we're dealing with, of course, are volume and temperature, because pressure is constant, number of moles is constant, so we're not worried about that. And they give you a practice problem here. So it says Charles' Law, a sample of neon gas occupies a volume of 752 milliliters at 25 degrees Celsius. What volume of the gas occupy at 50 degrees Celsius if the pressure remains constant? So pressure, again, is constant on this. So I'm going to go ahead and write down my variables that are given to me, and it's going to look like this. So let's see what's given. Of course, here's your variables. This is the formula we're going to use. This is Charles' Law. And so I look through and I go, all right, so it says, oh, there's my first volume. So that's V1. This is my first temp, right? Remember, you got to convert it to Kelvin by adding 273 to it. And then they give you, they want to know the second volume, so that's the question mark. And then they give you the final temperature. This is the second temperature, so that's 50 degrees Celsius. So you're going to write those in your given. And it will look like this. So boom, there it is. You're going to convert your temperatures to Kelvin. I did those quick down here, just showed you the work. And you got them both in Kelvin, that's good to go. And you're going to solve for V2. So we are going to make V2 the thing that we're solving for. So we'll go ahead and write our formula that we're going to use. It's written down right here. And I'm going to make V2x. You don't have to write it down as x, but I like to do that just because it makes it easier. And so V2 is equal to x because that's what they're asking for in the problem. So I'm going to go ahead and write these numbers right here into the formula and do my cross multiplication so that I can solve for x, which in this case is the second volume. So it's going to look like this. So boom, there it is. Here's my equation I'm using. I just substituted the numbers since I wrote down what was given. 725 goes for V1, 298 goes for T1. My V2 is X, so I'm just going to make that X. And I forgot my unit there. And then my T2, of course, was 323 once I converted that to Kelvin. So now I can cross multiply. I'm going to multiply down, and this is what you guys did in like the 6th or 7th grade. So 725 times 323. Put that in my calculator. So did I say 725 times 323 gives me that. And then I'm going to go ahead and cross multiply the x to the 298, and that's going to give me 298x. I'm just going to ignore the units for now. And then to get x by itself, as you know, you're going to divide both sides by 298, and that will give me my answer. So let's see what that is. So boom, there it is. Your X is the second volume, of course, which is 786 Kelvin. So your V2 is equal to that. Now, if you wanted to work it the other way, where you're going to rearrange the equation, I'll show you that real quick. So boom, this is what it looks like. I just pulled the same stuff. I was kind of running out of room there. It was kind of hard to see. So I'm going to go ahead and just use another piece of paper because I've got it. Why not? So remember, here was everything that was given, and this is the second method where you're going to rearrange the equation and solve for the unknown variable. And remember, here is the equation, the Charles law equation, that we got to set it up for. We can put anything in it and make sure we set it up correctly. And so I wrote the equation here. Remember, I want to isolate V2 by itself, so I need to get rid of this T2. And so the only way I can do that is multiply it, multiply both sides by T2. And so you can see T2 goes away, and then your equation then becomes T2 over T2 times V1 over T1 is equal to V2. Then I just rewrote it because I like to write my equal sign to the right of my variable. It's the same equation, okay? So then I'm going to just, now that I have it set up, I'm going to use the numbers that was given to me and plug it into this new formula that I just created, and then I'm going to plug and chug. It's going to look like this. Okay, so here's I just put the numbers in, right? Here's my T2, here's my V1, here's my T1. I got that from the problem they gave me. And so now I can plug and chug. And my plug and chug on this is basically 323 times 752 divided by 298. And then on this, you can see that my units of Kelvin will go away. What am I left with? Milliliters, and that is going to be the unit in your answer, and that's what you want. So I'll go ahead and plug this in, chug it out on my computer, and it's going to look like this. So boom, there is your answer. And then when I did this, I realized what I did wrong here on the first one. This should be 752, and I put 725. So that was a shot at getting some chocolate in the classroom that I'm sure one of you guys would have caught. But when you rework that and put actual 752, the answer then becomes 815 milliliters. So that was my mistake on this one right here, is right there. I transposed it, my dyslexia came out, and it shines sometimes when I'm thinking of other things, and it happens. So let's work the next problem. Okay, so you can see that the next type of equation that we're going to use is Gay-Lussac's. It says, of course, this is a direct relationship. On the graph, it looks just the same. Of course, this is my x-axis and this is my y. This one is dealing with pressure and temperature. Volume is constant, so it's not part of the equation. So your equation then is P1 over T1 is equal to P2 over T2. Okay. And so when you read these, you can work them the same way. Now you're just dealing with pressure and temperature. So this first one here, it says the gas in an aerosol can is at a pressure of 756 millimeters of mercury at 25 degrees Celsius. So here's my P1, this is my T1. What would the gas pressure be? So they're asking you for P2 in the can be at 45 degrees Celsius. So this is my T2. to pressure that was given. So I'm going to go ahead and write those givens out so that I know what I'm going to use to plug and chug in my formula. And it's going to look like this. So I'm remembering to convert my temperatures into Kelvin. Always convert them into Kelvin. Otherwise, you're going to get your answers wrong when you work these problems on those homeworks, those quizzes, homeworks that were given to you. So here's what my variables are. So I know I'm just going to solve for x. That's the method I'm going to use. It's the quickest for me. So I'm just going to put my numbers into the formula, and it's going to look like this. So bada boom, bada bing, there it is. Remember, here's the formula that I'm using. I've got my givens. I wrote them down. So my P1 was 756 millimeters of mercury. My first temperature is 298 Kelvin. I double checked to make sure that I had the right numbers there. I went ahead and made P2X so that I can solve for X, because this is the quickest method for me to do. You don't have to put the X there. You can keep it as P2. It doesn't bother me. So when I multiply 756 times 318, I get that number right there, big old 240,408. Then, of course, I multiply 298 times X. I get 298X. I am conveniently leaving out the units because I'll clean that up in the end. Because I know that a unit of pressure is going to be millimeters of mercury. My other two units will cancel out. So don't let that hold you back. And then I get X is equal to 808 millimeters of mercury. I'm sorry, it should be 807 because it's 806.7, so it should be 807. So I'll go ahead and make that quick change. And so it should be 807 millimeters of mercury for your second pressure. Okay. So I will leave this last one up to you. I'm just going to give you the answer, and then you should come up with the answer. Whatever method you want to use. If you want to use method 1, where you just solve for X, that's quick, or method 2, where you rearrange the formula and solve for the variable that you are being asked for, you may do that. Either way, you should come up with the same answer. So I'm just going to give you the answer, and then I'm going to close the Zoom session, and then you can go ahead and do the work to see if you come up with that answer. So here it is. So boom, there is the answer I came up with. If you come up with something different, let me know. If you got to this answer and you are happy with it, then you know how to do these problems. If not, then shoot me an email or a remind text, or come to the next Zoom meeting and let me know. I hope this helps, and thank you all for coming to the Zoom session. It's great to see you guys. Remember, stay healthy, stay safe, go out and get some exercise, get some sun. I know it's a little bit rainy right now, but my plan for today to beat this cabin fever is to go on a nice muddy bike ride in the trails with my younger son, and we're going to have a blast. All right, you guys, have a great day. We'll see you next Tuesday. Take care.